Bismillahirrahmanirrahim. Welcome to the video session of the course M180, and in this video we are going to discuss the topic called trees and binary trees. Here the main thing is what we are going to study is about the binary trees, but for that we need to know first what is a tree. So we are going to look some basic definition of the tree and some definitions or the terms related to the tree, and then we are going to look into in detail of binary tree and how to create a binary tree and how to process a binary tree, starting with what is a binary tree, okay, and then what are the different methods to process a binary tree, okay. Now let's start with a tree. Whereas a tree is a non-linear data structure used to represent entities in some hierarchical relationship, okay. For example, you say a tree of a family, so it starts with the forefathers and the father and the son and the grandson and all, okay. Also a tree where you can represent the contents of a book, whereas you have the title of the book under which you have different topics discussed in the books. Also the class inheritance in Java, where you have the base class, the root class, that is the object class, and from which the other classes are coming. Computer file system, for example, where you have the folders and subfolders finally leads to files. In the same fashion, decision trees and top-down design. Here is an example for the trees. In this example, showing the computer file system starting from the root directory, that is C. The C drive has different folders and different subfolders and so on. In the same fashion, we can also see a tree for a website design, wherein you have the home page, and then you have in the home page you have different links for other pages, okay. For example, over here there is a home page, and then you have the teaching, research and activities, and inside the teaching you have different courses, research papers and presentations. So this forms a tree. So these are some examples for the tree. So let us look a formal definition of a tree: a set of elements of the same type such that either it is empty or it has a distinguished element called a root, from where the tree starts and from which the descendant 0 or more tree will be there. So that forms the subtree, okay. So starting with a root element, for example, this is a root element which starts, let's say R as a root element, and either it is an empty without any root element, just a data structure without any elements, that's an empty. So even without there is no root, or it has a root, okay, that is a root, and it has some subtrees in the root, for example, okay. So here what is the base? This is a recursive definition for it, and the base case for this definition is an empty. When it becomes empty, you are going to go back again. Then the recursive part is the second part, where you have the root element and you have the subtrees, and every subtree has a root. For example, if this is a subtree, it has a root, again the elements, and so on. Here is a given as the root, this is the root, and these are the subtrees in the root. Now here let's some tree terminologies. In the tree we have a root of a tree, that is the node at the top level, we call it, from which all other the childrens will come, that is called a root node. And the line which is connecting from the node to another node, these lines, for example, these are called edges, okay. And the nodes which are and the nodes which does not have the children's. For example, these nodes, if you see these nodes which are in blue, okay, these nodes does not have the children's. These nodes which does not have the children are called leaf nodes, that is the end of the tree. And the nodes which are in between the root and the leaf is called it as an interior node. So you see this one which is in yellow marked over here, these nodes are called interior nodes. So here is the definitions for those terminologies. Node is the element of a tree, edge is a connection between the nodes, root is a distinguished element, that is the origin of the tree or the root of the tree, and in every tree there is only one root. Okay, leaf node is a node without any children's. Okay, interior nodes, a node that it does not, which is not a leaf. Okay, empty tree does not have any nodes, any edges. Okay, so with no nodes and no edges, we call it as an empty tree. Moving ahead, a tree, as we know, tree has a nodes and it has zero, every node has 0 or more childrens. If the node does not have the childrens, that node is called it as a leaf. And a node can have at most one parent. Okay, and this is about the tree. Now what is a binary tree? It is same as a tree, but in the binary tree every node will have 0 to 2 children per node. So maximum is 2 children. Maximum is 2 children for a node. So that type of tree we call it as a binary tree. So here, for example, this is not a binary tree. It is a tree but not a binary tree. Why? Because the node, for example, root has 3 children, and this node, the intermediate, has 3 children. So we does not call this as a binary tree, whereas this is a binary tree because in this one every node has 2 children. Moving ahead, a parent of a tree, a parent of a node is nothing but it's a node which is directly above to it. For example, if you consider this node, the parent of this node, for example, let's say this is P. The parent, let's say this is C. The parent of C is this one, which is P. Okay, so for example, for these nodes the parent is this one, and for these nodes the parent is the root node. Then child is nothing but, of course it is by default the child is the next node. The node below to the in the hierarchy, call it as a child. So for example, these are the children of the root node, and this is the child for this node, and these are the children for this node. Siblings, the nodes which have the same parent, we call it as a sibling. For example, these are the siblings because they have the same parent. Ancestors of a node, its parent and the parent of its parents, and so on. That is the father, grandfather, and so on. So for example, let's say this is a node C. The ancestor for C is these 2 nodes up to the root. Then descendants, its childrens and childrens of childrens are called the descendants. For example, the descendants for the root in this way is, these are the descendants. Also these are all the descendants for root. Okay. Size of the tree is the number of the nodes. So for example, if you want to say the size of this tree is the number of nodes, you just count the number of nodes. So it has 8 nodes, so the size of the tree is 8. Moving ahead, the height of the tree. First we see the path. This is a sequence of edge leading from one node to another node. We call it as a path. And we have something on the length of a path is the number of edges on the path. Okay, for example, let's say if this is a tree. Okay, now if we say the path from this node, let's say C to R, the path is 1, 2. Okay, the number of edges from R to C. Okay, and the length of the path is the number of edges. Okay, so it is, what is the length is 2 because you have 2 edges. Then height of a node is the length of the longest downward path to the left from that node. So for example, if you want to calculate the height of this node, for example, let's say this node is n. The height of n is 1 till the leaf. So from the leaf to this node, it's only one edge. Now height of root is 1, 2. Okay. In the same fashion, the height of a tree is the longest path. The longest path from the root to the leaf. Okay. For example, over here, let's say you have another node over here. Now what is the height of this tree? Is the path from the root to this, the last node. Okay, the longest one. 1, 2, 3. So height of the tree is 3. Now what is the height of a tree that has only a root node? The height of the tree with a root node is 0. And by convention, the height of a tree with the height of an empty tree is -1, because where there is no node. Then level of a node, that is called the depth of a node, is the length of the path to its root. Okay, that is the number of edges from the node to the root is called it as a depth of the node, also called the level of the node. So level of the root node is 0, because there is no more, it's not a leaf, it does not have the parents. Okay, does not have the root, it is a root itself. And the level of a node that is not a root is the level of its parent plus 1. Level of its parent plus 1. So let us, for example, let us take this tree for example. Okay, now here if it ask you what is the depth, let's say this is a root C, sorry, node C. This A, B, C, D and E. Now I say what is the level of this tree? What is the level of this tree? So it is the path from the root to the last node, to the leaf. So for example, let's say 1, 2. So it has how many levels? See, 1, level 1 and level 2, and the root has level 0. So it has level 1 and this has level 2. And if there is one more, this has level 3 and so on. Okay. Now here is a question, what is the height of a tree in terms of level? It is the same, that is the maximum level of the leaf. Now here is the different levels of a tree. The root node has always level 0 and the next has a level 1 and so on. Subtree of a node is consist of a child node and all its descendants. So for example, if this is a tree, now I can say that the subtree is, this is a subtree. Okay, that is subtree of this node is its children's, and if it does have sub-children's, these are all comes in this subtree. Okay, any node can have many subtrees. For example, this node can have again the subtrees over here. Now here is a subtrees. These are the also again the subtrees for E. Now let's see the degree of a node and a degree of a tree. The degree of a node is nothing but, also called arithmetic of a node, is the number of children's of that node. It's called the degree of the node. And the degree of a tree is maximum degree of tree's node. Any node in the tree which has the maximum degree is the same as degree of the tree. It is the degree of the tree. Okay, so let us take for example over here this tree. We'll consider this tree and we'll try to answer the following questions with the help of this tree. Now what is the height of the tree? The height of the tree is the maximum path from the root to the leaf. So it is 1, 2, 3, 4. The height of the tree is 4. How many descendants does the node J has? J has how many descendants? It is its children's and children's and children's and all. So it has 1, 2, 3, 4. So it has 4 descendants. What is the size of the tree? It is the number of nodes. It has 17 nodes. What is the degree of the tree? It is the maximum degree of a node in the tree. Now if you look into this one, the degree is nothing but the number of nodes it has. For example, C has 1, 2, 3, 4, 5 nodes, which is the maximum one. So the degree of the tree is again the same, that is the 5. And how many nodes are there at level 2? Now this is level 0, this is level 1, and this is level 2. So how many nodes you have at the level 2? There are 8 nodes at the level 2. Now what is the largest possible height of any tree with a degree 3 and size 100? Degree 3, it means with 3 nodes and its size is 100. Okay, 3 degree, 3 degree and the size is 100. So what is the possible number of what is the height of this tree? So it is 97. Okay, because 100 minus 3 with the degree and the size is 100. So 100 minus 3 is 97. Now let us look into the binary tree. A tree is whose nodes may have any number of children. It is a tree. Whereas n-array tree, okay, is a tree whose nodes have no more than n children. That is maximum n children. Whereas the binary tree, bi it means 2. So binary tree will have 2 children in maximum. 2 children in maximum for every node. Okay, or 0 to 2 children we can say. Then that is a binary tree has a degree with 2, and the children if present are called left child and the right child. For example, if it is this is a binary tree with 2 children. Now here the children can be defined as the left child, this is left child, and this is right child. Okay. Now here is an example of binary tree, whereas for the A it is the left and this is the right, B and C. Or also we can say this is a left subtree and the right subtree. Now recursive definition of a binary tree, either an empty tree or it has a root whose left and right are the subtrees. Okay. So a binary tree is positional tree, that is it matters whether the subtree is left or right. It has positions, that is left and right. So it's also called as a positional tree. A full binary tree is one in which every node has 2 children. Okay, not less than 2 children. Okay, every node has 0 or 2 children. That is called a full binary tree. Whereas a complete binary tree is it is same as a binary tree, but the maximum nodes are filled onto the left. So we fill all nodes as far left as possible. So a complete binary tree is a binary tree in which every level except possibly the last is completely filled and all nodes are as far left as possible. Now let us look into some tree traversal techniques. Tree traversal, it means we are going to process the tree to get the node values. Okay, to get what are the values at the nodes. Okay, there are 2 types of processes we have. Okay, or 2 approaches we can say, that is the depth first search and the breadth first search. Now let us study one by one. In the depth first search there are 3 different forms to visit the nodes in DFS. Depth first traversal, that is pre-order, in order and post order traversal. Now let us look into one by one. The pre-order, how we are going to traverse the nodes in pre-order. In pre-order we start from the root node. First we are going to process the root node, then we move to the left node and then move to the right node, so that we process all the nodes. Then in order we start from the left node, we've moved to the the root node, and then we'll go to the right node. In the same fashion, in post order, we start from the left, go to the right, and then go to the root. Okay, so I'll repeat. In pre-order, we start from the root node, then we'll move to the left, and then we'll move to the right. And in order, we start from the left, we move to the root, and then we move to the right. And in the post order, we start from left, we move to the right, and then we'll move to the root. Okay, so we can also write something, for example, something like this. In pre-order, we start from the root to left, and then from left to right. This is in pre-order. And in order, we start from left, then we go to the root, and then we move to the right. And finally, in post order, we start from left, then we'll go to the right, and then we'll move to the root. Now let us do trace this by using this pre-order and in order and the post order. Okay, so for example, let us consider this tree, and we try to traverse it by using a pre-order. In pre-order, it says start from the root, and then go to the left, and then go to the right. So the root over here is A, so first we'll get A, and then we move to the left. Left is B. Now you see B is again a root to its subtree. So we consider B, and then we move left to the B, because B is a root. So after root we have to process the left, we will move to the D. Okay, we process D, and D is again a root, but D does not have left. So root is processed, left is not there. What is remaining is right. I'll repeat. In D, root is processed, there is no left, so we have right. So root is done, left is not there, go to the right, that is H. Okay, and then go back to the B, because we process this, done, we return back to the B. The B is processed as a root, then it has a E, process E now, then go back to the right of the main root. Okay, right is again a tree, where is C is a root, so consider C as a root. C is a root, so process the C. Go to the left of the C, because it says root left, so left of the C is F. F is processed. Now after F has again left, which is F is a root and has a left I, so it processes I. There is no right, so go back to the F, go back to the C, because all this is processed. Remaining is G, the right of the C. So G is processed now. So your pre-order traverser for this tree is ABD HECFIG. So here let us look into the algorithm, the recursive algorithm for this pre-order. So if the tree is not empty, visit the root node, because in the pre-order first we visit the root node, process the root node, perform this to the left subtree. So in the left subtree we'll have the root, again the children's and all, so it will process the recursively, and then perform it the same to the right subtree. Now here, what is the base case? The base case is the processing of the root. Okay, and the recursive part is these two parts, performing the pre-order for the left subtree and to the right subtree. Now let us look into the in order. The in order says that first perform the in order to the left subtree, because in order first you process left, then you go to the root, and then you go to the right. So first perform the in order for the left, and then go to process the visit the root, and then perform the in order for the right. So let us take the example, the same example. We start from the left, because in order says start from the left of the root, then go to the root, and then go to the right. Now here A is the root, its left is B, so you go to the B. B is again a root. In this one B is a root. Now go to its left. D is again a root, but does not have the left. So what is after left? If there is no left, the after left is root. So you process the root is here. Now in this subtree the root is d. After d, go to the right, it is h, then go back to the b has, now process the b because b is the root. You finish to the left of the b, that is the left of the b. Now go to the root, process the root b, and then go to its right, that is e. Now the left subtree for the root a is processed. Now process the root now, that is a. So you process a and go to the right. Now right is again a subtree here. Process what here now in this subtree, process the left of the root. C is the root, left of is f. F is again a root for this subtree, left of it is I. Now process I, then process the root f. There is no right, process the c root. There is a right for c now. After c it is g, so you process g. Now here is your in order for this tree, that is dh bea if cg. Now moving to the post order. In the post order, first we start with the left, that is we do start from the left, then go to the right, cross the right, and then reach the root node. Okay, so let us take the same tree and try to put the post order of this tree. Now in the post order it says travel to the left, then go to the right of it, and then go to the root. Okay, so traverse the left, the root is a, its left is b. B is again a root because it is a subtree over here. Go to the d. D is again a root, so d it has a subtree dh. Then go to the d does not have the left, it has a right. So first left is not there, then the right is h. Go to the h, process h, and then process the root. Root is d, the nearest root is d. Process d, and then go to the right. Once you processed from this for this subtree, so you process this subtree, okay, and then the right of b. The right of b is e. Process e, and then go to the root b. Now the left subtree for the main root, that is a, is processed. Now go to the right subtree. Now you have to go to the right subtree because it is left and then right. Then right, c is again a root. From the root again you have to choose left because it's, if there is a root then you go to the left of it. Left has a word f. F is a root again for I. For this is again a subtree, so you process the left, then there is no right, process the root f, then there is a right for c, that is g. Process g and then process c. Okay, so this is, I'm sorry, we have finally left with the root a, then you process the root a. So this is your the post order traversal, that is ADEBIFGCA. Okay, so in the same fashion they'll ask you in the exam, might be that they'll give you the tree and ask you to process or traverse the tree by using the in order or pre-order or in order or post order. Okay, you have to remember the fashion, like how you have to move. Now coming to the breadth first traversal, what we have discussed till now or here, the three forms of the depth first traversal. Now here breadth first traversal, we are going to traverse the tree in the form of levels, which is also called as in level order traversal. So for example, if you consider this tree, it has the levels. This is level 0, this is level 1, and this has level 2. You process in levels. Okay, so we start from the left side, first level A, so we walk in order A, and then the second level, okay, go to the second level BE, and then the third level CDF. Okay, so this will be your traversal BFS. Okay. Here is a discussion. Note that the relative order of the recursive call in the pre-order, in-order, post-order traversal is same, but the only change is when you process the root. In the pre-order, first you process the root. In order, first you process the left and then root. And in post-order, first you process left and right and then go to the root. Traversal analysis, how many recursive calls are there at most with a tree having n nodes is it has 2 into n recursive calls. Okay, because you need to process two things, left and right. Okay, with the recursive calls with the n number of nodes. Okay, so you have the big O of n, the complexity is big O of n. Now here is an example and ask you to process this tree in pre-order, post-order and the in-order. Okay, so let us start, let us do this one. If you want to process it in pre-order, pre-order says that you have to move from you have to process in the fashion of root, then left and then right. This is the pre-order. Okay, so the first you process 14, that is 14, and then go to its left. It is a root now for this subtree, so it is 84. Go to its left, this is a subtree, the root is 13, there is no left, there is a right, 53, and go back over here to its right is again a subtree, it has 16 is a root, and then its left is 99, then its right is 72. Now go back again to the right of 14. Okay, we process this subtree, okay, along with the root. Now go to this one, this is a subtree now, it has a root 43. I put a comma in between so that it will be clear. Now 43, go to its left, left has a subtree with a root 33 and then 64, there is no left, there is a right. Now coming back to the 43, it has a right 97. So this is your pre-order traversal. Okay, so here it is 14, 84, 13, 53, 16, 99, 72, 43, 33, 64 and 97. Now let us do the in order. In order says let us do the post order, no problem. Post order says that first you process the left and then you process the right and then you process the root. Okay, so here if you go to this tree, the left is 84, 84 has a left, 13, 13 does not have left, it has right 53. So after left it is right 53, then the root 13, then again go back to 84, it has a right 16, 16 has a left, left is 99, it has a right 72, then its root 16, then its root 84, and then it's right for the 14 because root to be processed in the last, so it's right for the right. 43 is again a root, has a left again, it's again a subtree which has it does not have a left but has a right 64, and then root 33, and then it's right 97. Okay, and then 97, and then the root 43, and then the main root 14. So this is your post order. You see 53, 13, 99, 72, 16, 84, 64, 33, 97, 43 and 14. Now let us do the in order. In order says that left, root and then right. Okay, so left for this is 84, 84 is again a root, has a left 13, 13 does not have left, now the root is again 13, so start from 13, and then after the root it is right 53, then go back to the root, after the finishing this left, root is 84, then 84, after that there is a right, right has again a subtree, it has left 99, the root 16 and the right 72, then again go back to it, the root 14 and then 43, on the right it is a subtree has a root 43 has a left 33, so in 33 does not have a left, so it's root now 33 and right 64, this is done, then the root 43, then the right 97. This is the in order traversal. So it's 13, 53, 84, 99, 16, 74, It is 74 or 72? It is 72. I believe it is 72, 14, 33, 64, 43 and 97. So this is how we process the pre-order, post-order and in-order traversal. Now there might be a chance that they'll give you the pre-order and the in-order and ask you to draw the tree. Okay, now how to draw a tree for this one? We all know that the pre-order in-order method. In the pre-order, first it processes the root, then it goes to the left and then it goes to the right. And in the in-order, first is processed the left and then it goes to the root and then it goes to the right. Now here if you see, in the pre-order we get the root as the first element, so 4 is our root. Okay, now in the in order, if you see, it is left, root and right, and left of the root is the left subtree, right of the root is the right subtree. Now 4 is over here, to its left is 1 to 3, sorry 3 to 1, and to its right is 5, 6, 7, 8, 9. So in your subtree you will get the left and the right. In the left you have 3 to 1 and the right you have 5, 6, 7, 8, 9. Now let us look into this. The next, okay, the next over here in the pre-order it says 4, 3. 3 is on the left of the 4, so it says 3 over here. Okay, now if you look into the 3 over here in the in order, to its left it is 2 and 1. Okay, so it is 2. If you look into the 2, to its left it is 1. It is 1. So this is your left subtree. Now coming to the right subtree starts from 5. Okay, now here we finished with 1. What is the next number is 8. So the next is, that is after you process the left, it is remaining is 8. 8 starts with the right subtree starts with 8. Okay, now 8 has, if you see in the in order, 8 has on its left 7, 6, 5, on its right 9. So on its right it is 9. Okay, and on its left it is 7, 6, 5. So on its, if you look into the pre-order, after 8 it is 6. 6 on its left. Okay, and then if you see 6 over here in the in order, it is 5 and 7. 5 on its left, 7 on its right. We are done, all done, remaining with a 9. 9 is already in the tree. So this is your tree for this given orders. Okay, if you want to compare this. Okay, so here what you have to do is you need to do the practice. You need to do practice to solve this kind of problems. Okay, so I suggest you to put yourself the orders. Okay, first you put a tree, find the order, and then for the same order, okay, without seeing the tree, you construct the tree again. Okay, binary search tree, and the key properties over here is in a binary search tree. So we can use this binary tree for an application for searching for an element. Okay, so here we call it as a binary search tree. Now here the key properties for this is value of a node, and what is the based on the value of the node, we put the smaller values on its left and the larger values on its right. Smaller, it means smaller to x, larger it means larger to x. Okay, so any smaller value to be put on the left of the node, root node, and any larger value to be put on the right of the node. For example, over here you see these are the binary trees. If you see the smaller values comes on the left of the root, and the larger values comes on the right of the root. For example, in the same fashion over here, the smaller value is on the left and the larger values larger than this root node or comes on the right. This is not a binary search tree, okay, because there is a value 25 on the left subtree which is larger than 10. For example, in this binary search tree, what is the pre-order traversal? So you have to go the pre-order, okay. So the pre-order is what it says. The pre-order, it says first the root and then the left and then the right. So you have to calculate in the same fashion what we did, okay. The in order what you have to do, you have to calculate first left and then the root and then the right. So you have to do in the same fashion and you have to get this A B C D E F G H I. And the post order, sorry, this is not given over here. Anyhow, so here what you can do is you can calculate this very easily as I explained, and at the same time to practice how to create the tree, you can take these two, okay, and try to create the tree without seeing, okay. So it will be a practice for you how to create a tree from the given order sequences. So here is a post order for it. Level order is processed in levels. So in the level it comes F, then BG, then ADI, then CEH, okay, as it goes in levels. Operations of the binary tree, we can add an element to the tree. There are different operations: adding an element, removing an element, checking whether the tree is empty or not, finding a particular element on the tree, getting the size of the tree, and traversing the tree. That is the in order, post order, pre order, and level order. Now it is to add any node to the tree, okay. There are two methods. Either if it is a normal tree, we can add it randomly, or if it is a binary tree, we have to follow the binary search technique, okay. That is, on the left all the smaller values than the root, and on the right the larger value than the root. So let us consider you want to insert a node n into a binary search tree. We take the current as the root node, okay, and if n is before the current node, that is the smaller than the current node, then it becomes, and the left child for the current node is null, then you add there n. So for example, let's say this is the current node having a value, for example 10, and n is, let's say, 5. So 5 is before 10, that is smaller than 10, and the left of 10 is null, then you add 5 here, okay. This is one case. Else, if n is after, for example, let's say n is 15, that is after or greater than the root or the current node, and the right child is empty, the right does not have any child, then add this, insert this onto the right, okay. Else, if n is before current, repeat the same algorithm to its left subtree. For example, if it is a subtree, it has a subtree, for example, it has a subtree something like this, and you start from the root node and you see there is a subtree, then we repeat the same process recursively, making this as a root, where current is equal to current dot left. So we move from the current from the root to the left of it. If it is before, if it is less value than the root. If it is greater value, we move to the right subtree, okay, and we repeat the same process. For example, over here we want to insert 20 in this tree. So 20 is greater than 10, we move to the to the left subtree. I'm sorry, to the right subtree, because the greater value onto the right subtree. Now we check again for this subtree. Root here in this subtree is 30. 20 is less than 30, move to its right. Right has again a subtree, that is 25. Now 20 is less than 25. Now this can add it to its right, because it is less than, add to the right. So it is 20 is added to the right, okay. In the same fashion, for example, let us say you want to insert let us say you want to insert 35 in this one. Okay, now this is your tree 10. Now 35 is greater than 10, so you move to the right. 30 you have 35 is greater than 30, move to its right. 45 you have. 35 is less than 45, you add to its left. 35 is added over here, and the rest of your tree is this one. Clear? So I hope it will be clear for you. Similarly, when we add remove an operation, we remove from for an arbitrary choose, we remove, say that leftmost leaf. Okay, so if a random choice, what would happen to the children's? So for example, if you want to draw any the intermediate nodes, then what will happen to its children's? Okay, and what if the root is if you want to remove the root? So we have to follow some technique. Okay, so by using a binary search technique, we are going to try to delete the a node from the tree. Let us say you want to delete x from the binary search tree. So first you perform a search for x. If x is a leaf, that is the last node, you directly delete it, because it will not affect anything. There is no children for it. It will not affect, you can directly delete it. Else, replace the largest value y on the left subtree. On the left subtree. If it has, for example, if let's say this is a tree. Now, if x is a leaf, you can directly delete it. Now, let us consider it is not a leaf. If it is not a leaf, for example, if this is x, then what you have to do, replace the largest value y on its left subtree. If there is a largest value y, then the x, replace it on its in this place. Or a smallest value z. Okay, if there is no largest value over here, the smallest value z from the right subtree, you replace it and delete the replacement value of y or z from the subtree. What you have replaced, that you have to delete it. Okay, so here is, if for example you want to delete 25 here, so first you find the 25 is leaf, you can easily delete it. Okay, the result tree will be this one. Or if you want to delete here 10, which is the root. Okay, now here in its left, you can replace what it says, replace the largest value on its left subtree. So it has a left subtree, and the largest value to its left subtree is 5. So for example over here, it has a left subtree, it has 5, so replace 5. So in the place of 10, you are going to replace 5, and again to replace 2 over in this place and delete this 2. Okay, so this is how you are going to delete an intermediate node or a root node. Okay, the same, there is another example over here. Okay, linked binary tree implementation. How we can implement a binary tree in a linked list. Okay, now here in a binary tree, we have seen the things like root, and every root has left and right. Okay, so what we have to keep track over here is the root. Okay, and root has left and right, and count and keep track number of nodes in the tree. That number of nodes you should have in the tree. So first, how to represent a node is an element with a left pointer and a right pointer, to represent the left subtree and the right subtree, if there is any. If it is null, then this will be considered as a leaf. Okay, when the left and right is null, then this node will be considered as a leaf. If it is not null, then this node will be considered as a root. Okay, now represent a node in a binary tree is an element that here you are going to represent the element and its value, and it has a left referring to the left child node, and it has a right referencing to the right child node. Okay, so you have a complete implementation of this binary search tree using the linked list in the Word file, which is available on the LMS. Okay, so I hope you find this video useful and will help you in your studies for the coming exams. So you have inshallah coming final exams ahead. So I hope I wish you all the best, and I hope this video will be very useful for you. Thank you very much, and if you have any queries you can send me an email. As you all know my email, you can send me your queries, okay, on my university email, and I'll be happy to reply you. Thank you very much.